In this video, I want to talk about attributes. Attributes are the variables that live inside of the folders. To do that, I have the terminal open and I have created our definition for our example class. I'm going to call the constructor for this example class to create an object and assign it to the variable e. Now, remember, when we have an object, how do we access the attributes of the object? Well, we first give, the expression for the object, in this case, the variable e, then a period, and then the name of the attribute that we want to access, like say b. Now, of course, there's an error here, and that's because, there is no attribute b inside of this example object. Example objects don't have any attributes at all. How do I create an attribute? Well, how do I create any variable inside of Python? I just assign it. Could I do that? Well, let's try that. e.b is equal to 42. There's not an error. Something happened. And indeed, if I look at e.b, look at that. I now have an attribute b and its value is 42. Just to make this explicit, let's go over and look at the Python tutor. So here what I'm going to do is I'm going to define my example class, and then I'm going to create my example object, and then I'm going to assign it to be the value of 42. Let's go visualize this. So I have my example class. I have an empty class folder. My example object, that's an empty object folder. But now I'm going to step forward and look at that. The object folder is no longer empty. It now has an attribute b inside of it, which has a value of 42. So that's what happens with any object. If you assign an attribute that does not exist, Python's just going to create that attribute. So in assignment 3, if you were working with an RGB object and you misspelled red as rad, Python's going to create an attribute called rad inside of that object. I mean, spelling errors are a big deal in Python because Python just assumes you know what you're doing. If you tell it to assign a variable that doesn't exist, Python's going to create it no matter where it's going to create that variable. Okay, all right, so that makes sense, but what if I did something like this? Example.a is equal to 29. So in this case, I'm not talking about e, I'm talking about example. But that's okay because I actually have a variable called example, right? It refers to the class folder. And so dot means, inside of the folder. So wait, is this going to stick an a inside of the class folder? If I go step forward, indeed, that's exactly what happens. So I can have attributes that live in an object folder or inside of a class folder. If an attribute lives inside of a class folder, we call it a class attribute. If an attribute lives inside of an object folder, we call it an object attribute. All right, so I'll just go over and do this in the terminal. As you can see, this is correct. And I can now refer to the attribute a inside of example. Once again, dot means inside of the folder, whether or not I'm talking about the class folder, which I refer to by the class name, or the object folder, which I refer to by the object name. But now here's an interesting question. Suppose I type e.a. Now, if we look over here at the Python tutor, we'll notice that, there's no a inside of the folder for e. It's inside of the folder for example. So clearly this should be an error, except that it's not. Let's just go over to the Python tutor. You'll notice that I have a print statement to print e.a. You'll notice that I'm not doing any funny business here. It is printing out a value of 29 for e.a, even though there is no a attribute inside of this object. And this is not a case where the Python tutor is lying to me. What's happening? Well, remember, when we said dot, we mean, dot means inside of the folder. Well, which folder? Now, typically we mean, this is e, so it must be inside of the object folder for e. But if the folder is an object folder and it's not there, then Python is not going to give up immediately. You notice that in the Python tutor, we always list what is the class of our object folder. We see this example here. And when we've been drawing our folders in this course, we've always been writing the name of the class in the top right corner of the object folder. That's because if it's not in the object folder, Python will use that class folder as a fallback. So it sees there's no a inside of e, but it's not going to crash. Instead, it's going to go, let's go to the example folder and see if there's an a here. There is, and so that's the value that we're going to use. Now, of course, I could go add that attribute there if I wanted to. Now, if I ask what is e.a, I've changed it. It's 10. But what do I mean by changing it? Because if I go look at the class folder, example.a, I will notice that its value is still 29. What's happening here is that I now have two A attributes. Let's go watch this in the Python tutor. So once again, I'm going to define the class example. I'm going to create an example object. I'm going to put a B attribute into E. I'm going to put an A attribute in the class folder. And now when I say E.A is equal to 10, what that did was that put the A attribute inside of the object folder. So I have one inside of the object folder and one inside of the class folder. If I ask what is E.A, well, Python's going to tell me 10. Why is that? Well, I'm going to go to the object folder first, and I notice that there's a 10 there for A. Because there's an A attribute, I do not need to use the class folder as a fallback. It is only used as a fallback. But if I ask for example.A, now I'm saying, okay, I want you to go into the class folder, for example, and look for an attribute. And so I'm going to use this version of A instead. So one more thing that I want to point out, if I said example.B, there's an error. While it is true that an object folder can use a class folder as a fallback, a class folder cannot use an object folder as a fallback. Because, I mean, which object folder would it use? So it only goes one direction. All right, this makes a lot of sense. As we can see here, all right, we understand that we have class attributes and we have object attributes, and we're just creating these things with assignment statements. But in practice, this isn't what we actually do, right? We normally just call a constructor and everything happens for us automatically. Well, okay, so let's go look at one more thing. Because the issue here is because we have this word pass in here, which is telling us to do nothing when we define the class example. Let's look at a definition that actually does something. So you notice that now, instead of pass, I do have an assignment statement, one assignment statement. And you can see from the comment that what this is going to do is this is going to create a class attribute. Anytime that we see an assignment statement inside of the class definition, it's going to create that variable, but stick it inside of the class folder. Let's go visualize that. So there we go. Example now has this attribute A. When I create an E object, however, it is still empty. This only creates class attributes. It does not create object attributes. But that's okay, because if I ask what the value of E.A is, that's going to be fine, because Python is always going to use the class folder as a fallback. All right, so this looks a little better, but this isn't still quite what we want, right? Because in practice, we aren't typically working with class attributes. We're typically working with object attributes. Well, okay, to create object attributes, we cannot do that with these simple assignment statements. To create object attributes, we're actually going to have to learn a lot more about the class definition and see exactly what's going on when we do call this constructor function.